Hello. I would like to introduce you to our new version NACS 2.2 of our finite element software NACS. So let me at first begin with the new features in the NACS core. At first we have implemented faster solvers in the transient and the harmonic domain that allow faster computations of your tasks with NACS. Then, secondly, we have implemented the support for a directional coordinate system. If you imagine, for example, you've got a conducting device, and you've got input areas and output areas for the current that should be to describe the current flow in your conductor, then there will result a certain current direction. And that current direction you are now able to use, for example, prescribing a transversal isotropic material behavior to the conductor region. Maybe it's not a conductor in your case, but you can also use that directional coordinate the system for that use. Then in the magnetic domain we have introduced support for Biot-Savart coils. So with Biot-Savart coils you can describe the current coil piecewise by line segments. And the very interesting thing is that this is not a method bound to your mesh, so that is, you just describe it via certain coordinate locations, and this means it's much easier to place some coils or also coil variations in your existing computational domain. In the mechanical domain we were able to introduce support for nonlinear geometric behavior. That means if you've got large deformations, then you should use that nonlinear formulation in the mechanical domain. Also in the mechanical domain we introduced support for prestressing. So prestressing means that you have got a first static step where you do a certain computation and deform your structure using a force or maybe a prescribed displacement, and the resulting stresses will result in a modified material behavior that can be taken into account for further harmonic or eigenfrequency analysis. Then in the solver domain we improved our explicit solver. There we improved mainly the CFL criterion, the Courant-Friedrich-Levy criterion that is used to compute the critical time step for the explicit solver. And that computation of the critical time step depends on your mesh setup, especially on the smallest element, edge. And this is automatically computed by NACS and is now allows you to a much better performance for your transient simulations. Okay, let's change to the model viewer, to the NACS graphical user interface. So in the parameterization wizard we modified the model viewer. We have now the possibility to modify the background model that is always shown to the user. You can set how the point sizes and line sizes should be. You can switch between orthogonal and perspective projection in the visualization of your model. And we also introduced an automatic zoom to entities, which is especially useful when you're defining boundary conditions or also results, because then you will always see the entities that you currently selected for your boundary condition or also for your result. Another interesting thing is the visual support for coordinate systems, which might help our users quite a lot by defining the coordinate systems at the correct location. Then we come to the result viewer. There we also added a resize button that allows you to zoom onto the active result region, which might be interesting, for example, if you're interested in a transducer and its acoustic sound field. Maybe the transducer is very small, so you want to resize the visual domain or the visual region to that small transducer device and see, for example, the displacement of the transducer. And later on you're interested in the acoustic sound field. There, of course, you want to see the complete domain and want to see the acoustic pressure. and you can easily resize your view using a resize button. We also added support for the automatic ranging of your quantity. That means the color bar and the legend is always updated automatically. This might be useful for harmonic or modal analysis, so you don't have to resize for each analysis step. Then we also have added support for different color maps. And as last item in the result viewer section, we modified the XY plot widget that we are using. So now you can easily zoom into your analysis results, like the monitor point displacement, and there you can also see a transient domain. You can automatically compute the FFT spectrum of it. You can modify the axis scaling between linear and logarithmic scaling. You can turn on a grid and easily turn off the grid. You can change line styles easily, and mainly you can also export the graphical result into a graphics file. So the final section is about the interfaces. Starting with NACS 2.2, we added an interface for Trellis by CSIMsoft. So Trellis is a quite powerful preprocessor that allows geometry generation, a CAD import, and also to generate nicely meshes, also very large meshes with several hundreds of millions of elements. And we added a basic NACS mesh file generator interface for Trellis, and we will continue the integration of Trellis in the NACS graphical user interface within the next versions of NACS. We also improved our ANSYS Workbench interface. That means we have a tremendous speed boost in exporting ANSYS models to NACS mesh files. We also have the possibility to let the user generate the surface elements required for his simulation with a new edit command, gensurf_elements. And finally, we modified our write model command that allows the export of the mesh file. So now you can use at first the file names longer than 32 characters, which was a limitation by ANSYS APDL. And you can also deactivate the automatic mesh, the automatic surface element generation in case that you need a higher performance in writing the mesh file. So this is everything concerning the news about NACS 2.2. If you've got any support questions, please contact support@symmetris.de. For more information concerning NACS, please contact sales@symmetris.de. So thanks for your time and goodbye.